There is a place that physicists speak of only in whispers. Not because it is far away, but because if it exists nearby, we will never know. We would simply cease to be. The core of the sun is 15 million degrees. That sounds like a limit. It sounds like an absolute. But this is not even the beginning. Somewhere in the universe, there is a point, not a metaphor, not a theory, but a physical reality where the temperature is 100 times, 1,000 times, billions of times higher than what burns inside any star. And the strangest thing? It does not glow. It is not visible. It is empty. First, you need to understand one thing. Temperature is not heat in the usual sense. It is speed. The speed of particles hitting each other in a panic. The faster they move, the hotter it gets. And when that speed approaches the speed of light, the thermometers break. Physics rewrites its own laws. What we call hot on these scales ceases to be a sensation and becomes something fundamentally different, a state of reality in which the usual categories simply do not work. The first seconds after the Big Bang, not milliseconds, not microseconds. The Planck era is a span of time so small it has no name in human language. 10 to the minus 42nd power of a second. That is when the universe was hotter than any supercomputer built by mankind can calculate. Planck's temperature? 10 to the 32nd power kelvins. 10 to the 32nd K. A number that does not fit into the imagination, only into equations. It's not just hot. This is the point where space and time lose their meaning. Where the gravity you feel right now was indistinguishable from electromagnetism. Where there was no matter. Where there was nothing but this monstrous, blind, soundless heat. Heat that doesn't burn, because there was nothing that could burn yet. Heat as the only content of reality. But here is what no one expected. We reproduced it, right here, on Earth. The Large Hadron Collider in Geneva, an underground circle 27 kilometers long, along which protons fly, accelerated almost to the speed of light, close to the boundary beyond which physics forbids moving further. When they collide, for a fraction of a second, in a spot the size of an atomic nucleus, a temperature of 5.5 trillion degrees Celsius is created. This is 350,000 times hotter than the core of the sun. It's hotter than the universe was 1/1,000,000th of a second after it was born. Physicists call this state quark-gluon plasma, matter so molten that protons and neutrons cease to exist as separate objects. They dissolve in hot soup of quarks and gluons. This is not the destruction of matter. It is a return to the state of the first moments after the birth of all things. A collider is not a machine of destruction. It is a memory machine. It makes matter remember what it was before it became something. And here is a pause, because it breaks intuition. Such a temperature does not burn. It does not melt. It does something incomparably more terrible. It erases the structure of reality. There are no atoms, no molecules, not even protons. There is only primordial chaos that existed before the universe decided to become something concrete. But what happens when nature does this itself? Neutron stars, dead cores of luminaries that collapsed under their own weight. the size of a city, but heavier than the sun. Gravity on the surface is so intense that falling from a height of 1 centimeter is like crashing into a rock at a speed of 1,000,000 kilometers per hour. But that is only the surface. Inside, no one knows. This is the literal truth. The equations of physics begin to give several different answers at the same time.
Some models say that in the center of a neutron star, quarks are released. The same primary plasma as in the collider appears, only constant and stable. Other models predict something even stranger: strange quark matter, a substance more stable than ordinary matter, which, if it ever breaks out, can transform everything it touches into itself. If this is true, then every piece of rock, every planet, every star is vulnerable to a chain reaction that nothing can stop. This is not an explosion. It is a quiet, cold, irreversible consumption. A universe slowly rewriting itself into something for which we don't even have a name. When 2 neutron stars collide, and this happened in 2017, in a fraction of a second, energy comparable to the luminosity of all the stars in the observable universe combined is released.
The temperature at this point is again beyond measurable. Again, the Planck horizon. Again, that state where physics is silent. Scientists cannot explain what happens in these first moments of fusion, not because they didn't try, but because mathematics returns infinities. And in physics, infinity means one thing: the model is broken. Reality has gone somewhere where equations do not reach. Magnetars, neutron stars with a magnetic field so powerful that if one were half the distance from the Earth to the Moon, its field would rewrite the biochemistry of every molecule on the planet's surface. The iron in your hemoglobin would line up across the field. Your cells would rupture, not from heat, but from magnetism. Death without fire, without explosion, without a single sound. In 2004, the magnetar SGR 1806-20 produced a flash just 0.2 of a second long. In that blink of an eye, it released more energy than the sun has in 250,000 years.
That flare reached the Earth from a distance of 50,000 light-years, and it still ionized the upper layers of our atmosphere. It was recorded by satellites as an anomalous surge from 50,000 light-years away. If it had been closer, just an order of magnitude closer, this text would not exist, and no other either. Gamma-ray bursts, the most powerful explosions in the universe since the Big Bang. In seconds, sometimes milliseconds, they release more energy than the sun will radiate in its entire 10 billion year lifetime. At the time of the explosion, the temperature at the epicenter reaches hundreds of billions of degrees. The space around it is literally boiling with gamma photons of such energy that they begin to give birth to matter, particle-antiparticle pairs born directly from the void. This is not a metaphor, this is a real process. Light is so hot and dense that it becomes matter. Emptiness turns into substance because the temperature allows it. The boundary between nothing and something turns out to be not philosophical, but thermal. Some scientists believe a gamma-ray burst was the cause of the Ordovician extinction 450 million years ago, when 85% of all species on Earth disappeared. No trace of an asteroid, no volcanism of the required scale, just something there in the dark blazed, and the light came. Back then, only those deep underwater survived. Now, there is nowhere to hide.
There is data that is not published in popular magazines, not because it is classified, but because it is almost impossible to explain without something breaking inside the listener. In 2012, the Higgs boson was recorded at the LHC collider, the particle that gives mass to everything. Without it, matter would be just light rushing through the void, without form, without weight, without the possibility of ever becoming solid. It was a victory, but at the same time, physicists realized something else. The Higgs field, the same field that permeates the entire universe and makes matter matter, is unstable. Mathematics says that it exists in a so-called metastable state, like a ball frozen on the edge of a mountain. It is standing. It has been standing for 13.5 billion years. But if somewhere in the universe there is a high enough concentration of energy, a hot enough spot, the field can move to its true minimum state. This is called vacuum decay. At the speed of light, a bubble of a new vacuum would begin to expand in all directions, a bubble where the constants of physics are different, where atoms cannot exist in their current form, where the chemical bonds that hold your DNA together simply stop working. Not an explosion, not fire, just a quiet rewriting of the laws of nature. It is a wall that you cannot see, feel, or experience. It travels at the speed of light, which means no signal can ever arrive before it. No warning, no last moment of awareness. It just was, and then no. Some physicists believe that somewhere in the observable universe, this has already begun, that the bubble is already flying toward us. It is just that the light from this event has not yet reached us, and it won't get here before the wall itself. So far, this has not happened. Black holes. Outside, it is just cold, almost absolute zero. Hawking radiation is barely warmer than emptiness, but it's about what's going on inside, beyond the event horizon, in a singularity, a point of infinite density where everything that crosses the line falls. According to the equations of general relativity, in a singularity, the temperature, density, and curvature of space tend to infinity. This is not a metaphor for extremity. This is a mathematical way of saying this is where physics ends. This is where everything we know about reality ends and something else begins, something for which we have no name, no tools, and no chance of ever seeing. The event horizon is the literal boundary of cognition, not technical, principled, because everything that gets there does not come back, ever. No information, no light, no answer. 25,000 light-years from Earth, an object called Sagittarius A star is slowly spinning, the black hole at the center of our galaxy. 4 million solar masses. It is quiet now by cosmic standards, almost asleep, but not always. 2 million years ago, while the first Homo erectus were still learning to walk in Africa, Sagittarius A star woke up. A gas cloud fell beyond the event horizon. The black hole flared up. It threw out 2 cones of plasma perpendicular to the plane of the galaxy. These emissions, called Fermi bubbles, are still expanding today. Their size is 50,000 light-years, larger than the diameter of the Milky Way. The temperature inside these bubbles is tens of millions of degrees. They are passing through the galaxy right now, at this very moment. We exist in the cooling echo of that catastrophe. We are at the tail end of an event that happened while our ancestors did not yet know how to talk. This is not history, this present is just very, very slow.
And Sagittarius A star does not sleep forever. A new cloud of gas is moving toward it. A black hole eats, slowly, drop by drop, but it eats. When the next big cloud arrives, it will wake up again. It will again throw out cones of plasma with a temperature that physics has no words for. And this time, the geometry may lie differently. Dark energy. That is where the real anxiety begins. 68% of the universe is her. Not dark matter, which at least attracts, at least interacts gravitationally. Dark energy does not attract. It is repulsive. It causes the universe to expand, and expand faster and faster. No one knows what it is. Literally. This is not the modesty of scientists. Humanity does not even have a working hypothesis about the nature of what constitutes 2/3 of reality. We move through something without having the slightest idea of what it is.
If dark energy is growing, the scenario is called the Big Rip, a point in the future when it will become so powerful that it will begin to tear apart not only the space between galaxies, but the galaxies themselves, then the star systems, then the planets, then the atoms, until protons fly apart in the last fraction of a second before the finale, and the electrons and the quarks themselves. This is not an explosion. This is a stretch, a slow, unstoppable, indifferent stretching of all that exists to zero. And then, at the moment of rupture, the temperature will break through the ceiling again. Again, the Planck limit. Again, the state from which the universe once emerged. The circle will close. Or maybe it won't, because there is another pattern, the Big Bounce. The idea that our Big Bang was not the first, that before it there was another universe that shrank to a singularity and bounced back. It gave birth to a new one, ours, and so on, endlessly. A cycle of contractions and expansions, each of which begins with absolute heat and ends with absolute cold. If this is true, the hottest place in the universe is its past and its future. At the same time, Alpha and Omega sewn into one point, the continuous birth and death of reality in a fire that does not warm, because there is nothing left that can feel the warmth. Let's return to the question that has been hanging from the very beginning. What is temperature really? On the scale we're discussing, this is not something that can be felt. This is the measure of chaos, the measure of information. The higher the temperature, the less order there is, the more randomness, the closer we get to a state where the differences between particles are erased. At the limit, at the Planck point, there are no more particles. There are no more differences. There is only energy, indistinguishable from space, indistinguishable from time. Hot means less definite, more primary. The hottest place in the universe is the place of least certainty, a place where the universe has not yet decided what it will become, where everything is possible and nothing is fixed. That was in the beginning, and it is repeated in every collision of neutron stars, in every gamma-ray burst, in every cycle of the collider. These are small windows into a state of pre-reality, moments when the laws of nature seem to remember that they don't have to be the way they are. Why is the speed of light exactly what it is? Why is the gravitational constant like this? Change any of these numbers slightly, and the atoms will not add up. The stars will not light up. There will be no life. This is called the fine-tuning problem, and it does not have a generally accepted answer. Perhaps there are an infinite number of universes with different constants, and we are just in the one where they fit. Or there is a deeper structure behind the constants, which we have not yet discovered. Or, and this option is the quietest to pronounce, all of this is not accidental. But whatever answer is correct, it was born there. At that point of absolute heat, in the first moments when the universe chose its laws, or when they chose themselves, in a fire so hot that the very idea of choice lost its meaning. The hottest place in the universe is the moment everything is born, and it is not in the past. It repeats itself over and over again. In every flash, in every collision, in every experiment where people try to look beyond the edge of the known. We are not observers of this story. We are part of it. We are the cooled ashes of that first explosion that somehow learned to look at the fire and ask, "Where are you from?" And the fire is silent.